Hello, welcome back. The title of this lesson is called The Median of a Data Set, Part 1. So here we're going to learn how to find the median of a set of data, but mostly I want you to understand why we even care about the median when we already have a way of finding the center value of the data, which we already learned, called the mean. So mean is what we learned before. Here we're learning the median. So let me illustrate by an example. Let's say that you're in a neighborhood and you want to find the average or the center value of the data, let's say, of the prices of the houses in your neighborhood, right? So if they're all in the same neighborhood, they're probably all going to be similar price ranges, right? But if you want to find the average price, what would you do? You would just add up all of the cost of all of the houses, that's the data, and then you would divide by the number of houses. So if there was 5 houses, you would add up the prices of all the houses, and then you would divide by 5. That would be the mean. That makes perfect sense if all of the data is kind of in a similar range. But what if you had an outlier? What if you had an outlier? Let's say that all of the houses in the neighborhood were all similar ranges of price, but then you had one king that had like a $20 million house. So let's say all of the houses were like, I don't know, $80,000 or $100,000, but then you have one guy with a $20 million house because he just loved the area. Well, then you would have to find, let's say you wanted to find like the center value of that data, because in statistics we want to find the center, but also later we'll learn how to find the spread, how spread out the data is. So let's say we find the center by calculating the mean. So we add up all of the original 5 houses that are all around the same price, but then we add the 6th house in, which is $20 million. Then we divide by, now we have to divide by 6 because we have 6 houses. What's going to happen is it's going to calculate a mean. That's going to actually work fine, but the mean is going to be very far away from most of the data because the $20 million value is going to pull the mean really, really far up high. And if you tell me, oh, the average price of a house in that neighborhood is, I don't know, $16 million, then you might think it's a really rich neighborhood. But actually, most of the houses are way down here, not that expensive, and you only have one person, one house that's just an outlier, right? So outliers can be real like that with a real house and a real price, and you just don't want to count that one really because it's just an outlier. It's not representative of the bulk of the people that are there. Or it could be an error in the data. Maybe instead of $20 million, when they typed it into the computer, it was really only like $20,000 or $200,000, and they just had a couple of zeros there. That would be an error. So when we collect statistical data, we oftentimes don't want to look at the outliers. I mean, sometimes the outliers are important, but sometimes it could be an error, just wrong, or it could be that even though there is a guy with $20 million house, it's not representative of the bulk of the people, so we don't want to consider it. So we don't want to calculate a mean for that when there's an outlier, because if we find the mean, that mean is going to be skewed way, way far away from the bulk of our data. So what would we do? We have something here called the median. The median. It's going to be easier if I illustrate the median with less numbers, okay? So here we have numbers here. You can think of this as instead of prices of house, think of it as the prices of a hamburger, something like this, okay? What we want to do is we want to find the median of this data. The very first thing you do is you order the data in order. The very first thing you do is put the data in order. So in order to do that efficiently, let me just write the data set down again. 8, 4, 10, 7, 6. There's only 5 numbers in that data set. So let's rearrange the data set and put it into order, right? What is the smallest? You want to order it and put it in order of least to greatest. The smallest number is 4. Put a little dot under there, just show myself that I've already picked it. Then 6 is the next largest. Then 7 would come next. And then 8 would come next, and then 10 would come last, like this. All right? So here we have it in order from least to greatest. So we didn't really have to do that when we calculated the mean, because for the mean, we just add them up and divide. But for the median, we're not adding anything up, so we want to just put them in order from least to greatest, always. So we start at the smallest data value, and we put them all in order, okay? The next thing you want to do is you want to identify the center value of the data. So literally you're looking at the data and you're identifying the one that is in the exact center. So one way of doing that is to notice that we have 2 data values off to the left that we can kind of group together. And we have 2 data values off to the right that we can kind of group together. And when you put your hands over these 2 over here and these 2 over here and kind of pull them apart, you can see that this one is actually the one that's in the center. So then we just literally label that one the median. The median is equal to 7 in this case. So notice we didn't do any calculation. We didn't add up or divide. We didn't do that, and I'll explain why when we get it on the board more, because it helps us eliminate outliers a little bit easier. Because we didn't calculate using all of the data points. All we did was find the one that's literally in the center, right? So let's first start by plotting the numbers here on a line plot. So we had a 4, or let's go over here. We had an 8. We had a one house that was, or one hamburger that cost $8, one hamburger that cost $4, another hamburger cost $10, another hamburger cost $7, and another final hamburger cost $6. And according to our calculation, we are basically saying that the median is exactly equal to 7. So I'll just put an arrow right here, median equals 7. So median, you can kind of think the word median means middle value. It is not a calculational thing. It is literally the middle value, right? And it's the middle value because literally we look in our data set, it's the middle value when you order the data from smallest to largest. You have to order it first, and then you figure out the one that's literally in the middle. And if you think about it, that kind of does make sense because what we're trying to do is find a middle value. We're trying to find a value that represents the center of the data. The center of the data is important. Also later, the spread of the data will be important. So the center of the data is literally what we're finding here. We're not calculating anything. We're just literally lining the data up and then picking the value in the middle. And we're using it to represent the middle of the data. So you can see for this particular case, we have exact symmetry. We have these 2 points that are to the left. We have these 2 points to the right. We have one point which is where our median is. And so it's exactly the center of the data point. So a lot of students, in fact, every student that I've ever talked to, the very first thing they want to know is, okay, I get it. We want to find the center of the data set. I get it. But why do we have 2 different ways of doing it? Why don't we just have one? I mean, we already calculated the mean by adding everything up and dividing. If we were to find the mean of this, we would add these up and divide by 5. Why don't we just do that? Well, this is the reason why. So I really need you to pay attention because this is the central thing. What if these are the prices of hamburgers, right? And then let's say I had an outlier hamburger. An outlier hamburger that, here's $8 hamburger, $4 hamburger, $10 hamburger, $7 hamburger, $6 hamburger, and then a $200 hamburger. Right? What could be going on with the $200 hamburger? There's a couple of things that could be going on. Well, that could really be a $200 hamburger that's just really tasty. It's made with the finest ingredients. It's just cultivated by elves, and it's just amazing. It's got gold leaf when they wrap it up in the container, right? And it's amazing. Or it could be an error. It might be a $20 hamburger or a $2 hamburger, and it's just input into the computer incorrectly, and it's not real. So when you have an extreme outlier like that, if we were to add up, if we were doing a mean calculation, we would do 8 plus 4 plus 10 plus 7 plus 6 plus 200. And then we would have to divide by 6 in that case. And it would skew it because we're calculating, including the outlier, it would pull the mean way far to the right, and it would be the correct mean. But the problem is that single data point outlier would pull the mean so far away from most of my data that I wouldn't have any trust that it's really representative of the real prices of hamburgers in the area, right? So you would be allowing a single data point to just destroy the value of the mean that you're calculating because it doesn't represent the actual center point of the data set you have. That's the bottom line. But with this median, right, what would happen if I had a $100 hamburger here? Well, the $100 or the $200 hamburger here, the 200 would be in the data set, but we're not actually calculating including the value of the 200. We're just lining them all up and we pick the one in the middle. So it would have a little bit of an effect, but it would not nearly have as much of an effect because we're not actually adding 200 in and dividing. We just line them all up. Yeah, $200 hamburgers at the end, but when we find the center point of the data, it's not going to be pulled to the right, at least not very much, toward 200. So the bottom line is all of that talking is saying we have the idea of a median that we mostly want to apply when we know we have outliers in our data. When we know that we have the guy with the $20 million house, we want to use a median calculation because then we're not going to really consider that outlier as much when we line them all up and just pick the middle of the road number, and then it will be more representative of our actual data set because we always worry that these outliers are not really real. We always worry that these outliers are just errors and they're not really real, okay? You don't really know. Maybe you want 10 or 15 outliers before you're sure that it's a real thing. All right, So we line the data up, we group two over here to identify the center, and that center is called the median. All right? It's just another way of finding the center of a data set. Now let's take a look at the following. These will go faster now that we know what we're doing. So we have 32, 27, and so on. Let's say this is the, of my friends that I have, this is the age that they were when they first had a child. The age that they first had a child. So this person was 32 years old when he had, or she had her first child. This person was 27 years old when they had their first child. This person was 22 years old when they had their first child. This person was 24 years old when they had a child, their first child. And this person was 30 years old when they had their child, all right? If we were finding the mean of these people, right, then what we would do is we would add up and we would divide by however many we have. 1, 2, 3, 4, 1, 2, 3, 4, we divide by 5. But let's just pretend for a second that we had an outlier in this data. What if we had all these ages and they had their first child, and then we had, 100 years old when they had their first child. Now, you're probably not going to believe the 100-year-old data point. It's probably not right. I guess it's possible, but it's probably not right. But if you find the mean when you have an outlier like that, then you're going to be adding 100 years old in, and you would be dividing in that case by 6 because we'd have one more data point. And it would pull the mean so far away from this data that it wouldn't really represent the data anymore because we don't think that the 100-year-old person really is having their first child then. It's probably bogus data. It's probably not real, right? So let's find the median of this data and see how it would work out. First, I'm going to rewrite the data set. We had 32, we had 27, we had 22, we had 24, and we had 30. The step number one is we always have to order the data least to greatest. Least to greatest. So the smallest number here is 22. The next one here was 24, right? This one. And then we had 27. And then the next largest one is 30. And then the next largest one is 32. All right, so 22, 24, 27, 30, 32. And those are our 6 numbers, or our 5 numbers. All right, next, we want to find the center. I think you all see this is the center, but you just double check by grouping these together. We have 2, we can pull those away. We group these together, we have 2, we can pull those away, and we can see that there's only a single value in the center, so the median is equal to 27. The median is equal to 27. So we go in our chart here, and we just go and put I guess we could put a dot right here, and we could say median equals 27, just like we could over here. I'll just back up the truck because I forgot to do something. We said the median was equal to 7. I'll put a little dot right here. This blue dot means the median is equal to 7 over there, and the median was 27. So you wouldn't say the average, because the average means the mean. You would say the median age of a woman when she has her first child in this region or whatever is 27 years old, right? Now let's consider the case if we had the same data with an outlier. Let's say we had all the same data, but then we had the 100-year-old person. Remember, when we find the mean, the 100-year-old person is going to, because we're calculating using that number, is going to pull the mean far away. But if we had 100 over here, then we would just be lining them all up. We would not calculate using the 100. We'd just line them all up. The 100 would be at the end. We would still find the center of the data set, but it wouldn't really skew it the same way that it does here. So again, if we have an outlier in the data, the median is superior because it still gives a representation of the bulk of our data that we think is right, while kind of not giving very much weight to the outliers that are there. There's a little bit of weight that those outliers are there because it is at the end of the data set, but we're not calculating it and folding it into the calculation, so it doesn't impact it as much. So in this case, the median was 27. All right, let's take a look at problem number 3. We have 52, 49, and all this stuff. Let's say that these ages, we have 1, 2, 3, 4, 5, 6, 7. These ages represent the age of, let's say, retirement in a certain city. I mean, this is just made up. I'm just making it up. It could be whatever. It could be the number of donuts you eat over the course of a year, whatever. Let's say this is the age that people retire, right? So let's first of all see what the data looks like. 52. We have one person retire when they're 52 years old. We have one person retire when they're 49 years old. One person retires when they're 51 years old, right? One person retire when they're 55 years old. One person retire when they're 50 years old. and then we're here at 59. One person retire when they're 59 years old, and then one person retire when they're 56 years old. So let me just double check myself. So 49, 50, 51, 52, 55, 56, and 59. So that's the data here. What would the median look like? Let's first write down the numbers in their existing order. 52, 49, 51, 55, 50, 59, 56. And I want to reorder this data from least to greatest. So the smallest number here is actually 49. That comes first, right? And then after that, after 49 is going to be 50. 50 is right here, right? I have a 51 right here, right? I have a 52 right here. What do I have after 52? I have a 55. That's the next largest one, 55. And then I have 56 right here. And then the only one left I have is 59. See why I put these dots under here is to show me when I've written one down, so I always make sure that I catch them all. All right, now we want to find the center value of this data. We order it from least to greatest, and we literally are trying to find the center of the data. Most people, I think you could see that 52 is in the center, but a better way to do it is to try to group. We're going to group those three, and then we're going to group those three. And we know now that if we pull those three away and pull those three away, this one is the one in the center. So the median is equal to 52. The median is equal to 52. So we go back to our chart and we find out where is the median here. Put a little dot right here. Median equals 52. Now this is a representative value for the center of this data set. Now this one looks a little bit different than before, so we want to spend a few minutes looking at it. Notice that it's not literally in the center of the graph, it is pulled to the left because we have 4 data points that's pulling it this way and only 3 of them over there. So the median still is pulled to the left and to the right by the bulk of the data like the mean is, right? But the difference is that we don't calculate a value for the median using the numbers. We don't actually add them up and do a division. We just line them up and pick the middle value. So if we had an outlier in this data, let's say this is the age at retirement. Let's say instead of a very high age, let's say we had an accident in the data entry and we had a 5-year-old in here. No 5-year-old is going to retire, right? So this is the age at retirement, let's say. And we have a 5. We'll put a little 5 right here at the end. Right? Well, if we calculate the median, then what would happen is we'd put a 5, because we'd be ordering from least to greatest. We put a 5 here. We would line them all up, pick the middle value. It would skew it a little bit, but not very much, because we would essentially be almost throwing out the outliers, just looking at the center of the data values. And so it would skew it a little, but not as much as if we found a mean. If we found a mean, we'd have to add all these up plus 5 and then divide, and the 5 would be drastically skewing it one way or another, so far that we would not even really find it useful. So the median is superior in cases when we have outliers, right? And so this is what we have here. Line them up, least to greatest, find the middle value. Now notice that in this problem, the median was literally in the center with equal number of points to the left and to the right. Here, the median was literally in the center with equal points to the left and to the right. So sometimes that can happen, but notice that there's no symmetry. Symmetry is when there can be a mirror image, on both sides. This data is not symmetric. We have a cluster of 2 here, a cluster of 4 here, and then one guy, you almost might say he's an outlier, sort of, way over on the end, right? So there's no symmetry here. So the best you do here is you say, well, this is the median right here, but you can see that it does represent the center of the data because this is only 3 points, this is 4 points. It should be farther this way, and this is a good representative value. So if we were to calculate the mean and compare it to the median, we'll find that probably in this case, they're not too different. And in fact, in future lessons, we will be calculating the mean and the median together just to see the difference. They're just different ways of finding a center point of the data set. Now, I do have one more that I want to work here, so let me put it up there, and then we will wrap up this lesson. All right, let's take a look at this last problem, and I really want you to pay attention to this one because it is different than the other one, so you have to watch this in order to understand how median really works. Here's a data set, 450, 10, 9, 9. Let's say this is the number of donuts a child eats per week, let's say, or per month, right? Let's say per week, why not? in a certain place. So this child eats 4 donuts in a week or in a month or whatever. This child eats 5 donuts. This child has no donuts. That's a sad story. This person has 10 donuts, 9 donuts, 9 donuts. Okay, so let's first of all see what the data looks like. So this child ate 4 donuts in a week. This one had 5 donuts in a week. This one had 0 donuts in a week. This one had 10 donuts in a week. And this one had 9 donuts in a week, and a totally separate child also had 9 donuts in that same week. So just guess, before we do anything else, where would the median lie? The median is supposed to be a center value of this data, trying to give you a measure of where the center of it is. It can't be here, because this is the center of the graph, but we only have 2 points to the left, and then we have 3 points to the right. So it has to be skewed over here somewhere, because these 3 points are going to pull it to the right. So it's going to be somewhere in there, something like that. Right? So let's first of all write down the raw data to find the median here. 4, 5, 0, 10, 9, and 9. And then what I'm going to do is I'm going to rewrite the data from least to greatest. You have to order it from least to greatest to find the median, right? 0 is the smallest value, followed by 4 and then by 5. So I'll put a 4 here and then a 5 here. And then we have the 2 9s. Right? And then we have finally a 10. So we have least to greatest. Now we have to pick the middle point of the data. Now this one is a little harder because you can see that I have 6 data points altogether. So the middle is really right here. You know, there's 3 points to the left and 3 points to the right. It doesn't appear that there's a middle value here, right? In fact, if you try to group the left and the right ones, you could say like this is the left 3 data points, and this is the right 3 data points. So if I separate them, there is no value in the center. Look at the previous problems. When I grab the 2 on the outside, and on the outside, both sides, and pull them apart, I have 1 value in the center. That's the median. When I had these 2, I pulled apart, and I had a single value that I called the middle of the data point there, of the data set there. That was the median. So I had a middle value here. I have a middle value here. So it appears that when there's an odd number of points, here's 1, 2, 3, 4, 5 points, I can find a middle value. When there's an odd number of points, this is 5 values, I can find a middle value. But when I have an even number of points, when there's 6 or 8 or 10 or 12 or 14 data points, there's never going to be a center value. So what do? Well, in the case when you have an even number of points and you can't find a center value, what you have to do in that case is find the 2 most center values. The 5 and the 9 are the 2 in the center, and then we're going to average these together, right? In other words, we're going to find the mean only of the 2 most center values. So we're still finding the center values, but because we can't find 1, we just find the central 2 values and just find the average of them. All right, so how do we find that? We have to take 5 plus 9, right? We average them by, say, 5 plus 9. What does that equal? 14, right? 14. And then we take that number. We have 2 numbers here. We say 14, and we divide that by 2, and what do we get? 7. So what this means is that the median is equal to 7. The median is equal to 7, right? So that's the final answer. And so let's go up to the main chart here. The median is equal to 7 right here. I'll put a little circle right here, and we'll say median equals 7. Now, first of all, does this make sense? Is this more or less roughly what we predicted ahead of time? We said this is the center of the graph, but the median can't be there because we have all these points. It must pull to the right. And this is roughly where we said it would be. The median is equal to 7. And this is the central value of the data set that's giving us an idea of the center of the thing, because some points are to the left and some points are to the right, and it's trying to find that middle value. So if this is the number of donuts these kids were eating in a week, then you would say the median value of the number of donuts these kids eat is about 7, right? Now, why would we use this over a mean calculation? Well, if there was an outlier, what if you had on the other side of this 9, maybe you had 35? I mean, it's probably unlikely that somebody ate 35 donuts. It's an outlier. It might be true, or it might be a typo, and it might not be right at all. But if you found the mean using an outlier like 35 or 40 or 50 donuts, then you would have to add up these numbers, including the outlier, and divide, and that outlier would pull the data set, the mean value, very far to the right, and it wouldn't be representative anymore. But with a median calculation, even if we had an outlier out here, then we're just going to pick that middle value. So it does affect it a little bit, but not nearly as much as the mean. So the bottom line for the median calculation is we use it when we don't, or when we suspect that we might have outliers in our data. The $20 million house in the neighborhood, that's an outlier. Somebody eating 50 or 60 donuts in a day or whatever compared to this data, that's probably an outlier. Somebody makes a salary of them, $90 million a year, that's probably an outlier. So we don't want to include all the time these outliers because they may not be real, and even if they are real, they may not really be representative of mostly what we're trying to study. And the median essentially throws out the outliers because the outliers will always be at the end, and we're always going to find the middle values for the median. So all you do to find the median is you just line the data set up from least to greatest, find the middle value. When you have an odd number of numbers, there will always be a middle value. That's what the median is. But if you have an even number of data points where there is no center value of the data, then you just separate the data set into two groups and you find this middle two values in the center and you find the average of them. Add them up, divide by 2, and that is what your median is. So a little bit different process if you have an even or an odd number of data points, but it's still not too bad, right? So I'd like you to practice all of these yourself. Make sure you understand what the median is really for. Follow me on to the next lesson and we'll conclude your skills with finding the median of a data set.